initial rerun. Okay, real quickly on our test for independence, let's review that we got conditional is this section right here in the middle. Conditional probabilities is this section right here in the middle that has two things happening. And our marginal probabilities are these things in the totals that have one thing happening. Okay, so we're going to test independence and we're going to see if the fact that you are one event occurring changes the probability of the other event. So is the fact that B is occurring changing the probability of A happening? And so I've shown that here. Overall, version B is 54%, and that's coming from our marginal 54%, but the probability of version B happening, given that you are male, would put this whole probability of male on the bottom. That's 0.4, and male and B is 0.18. So that's a total of 0.45, which has reduced. Overall, it was 0.54, but if you are a male, it's 0.45. So they are not independent because the fact that you are male lowers the probability of preferring version B. And then you know what? Do put the actual number, statistical support. So then I would write here 0.54 versus 0.45. All right, so let me give you a moment to do the example 2. See if you can fill that in. See if female and version A are independent events. Okay, let's go ahead and check your numbers. Let me see how you're doing so far. Overall, what's that rate of females? 0.6, okay? So the marginal for females is 0.6. But then we say, I wonder if I went and put all of the version A people in one room, what proportion of them would be females? Okay? So out of all the version A people, and then I would put the A and females on top, okay? So how much is the total, the marginal version A? All of the version A's is how much? Okay, 0.46. And who are the female version A ones? Female and version A? Okay, so that's what we would be looking at here is 0.46 for the bottom, and then, so 0.46 for the bottom, and then 0.24 for the top, and then we're going to look and see what percent that is. Okay, and that ends up being, I think it's 0.52. Okay. So then we go, hey, what happened? Overall, 60% of my sample is females, but when I just looked at all the version A people, how much percent of them are females? Only 52%. So what has happened? The rate changed. And if the rate changed, then they are not independent because the fact that you prefer version A makes it what? More or less? Makes it less likely, good, that you are a female. And then I support that with actual statistics. 0.6 versus 0.52. Okay. All right, very good. Okay, so that's the test for independence. Now, I will tell you one other thing. Frequently, you would have to make this up right here, female and then female given version A, or you know, if I just showed you the top of this problem and I said, are gender and model preference independent? Okay, then where would you go with that? You would pick one or the other. So pick one. Somebody tell me one thing. Male. Okay, so then I'm going to go with male overall. And then that would mean my conditional needs to start with male and say, given that, and then I pick one of the other things, which would pick one. Okay, version A. So then I would work that out and see if the fact that you like version A changes the probability of you being a male. Okay. All right. So let's make up one more. Okay. Pick another way that you could test this. Probability of picking overall one. Version B. All right. Now pick a conditional one. But what do I start with? Version B. Given that, what goes next? One of the genders. Any of the genders. Okay. And so if you pick male, fine. Then we've kind of done that problem. And there you go. Okay, so that's how you would come about this. There's lots of options for how you can set it up and check for independence. Okay, moving on. Next, part 4, or the last thing in this chapter, is this technique of a tree diagram. Okay, and so first thing I want to do is tell you, when would you use this technique? When would this be something that you would say, hey, I need to use that tree diagram thing? Okay, so here's how it goes. You ready? If you start reading a problem, okay, if you start reading a problem and you've got several if this then that statements, if you got several if this statements, then you probably would do good at organizing this in a tree diagram. Okay, so you would want to use this if you have several conditional statements. And those are if then. You know, have you done any programming? All right. So, for example, this problem is about Leah, who is flying from Boston to Denver, but she's going to stop in Chicago in the middle. Chicago, so she's going to go from Boston all the way over here to Denver, but she's going to stop in Chicago. Okay, so she's got to do that trip there. All right. So here we go. Let's read what's going on, and you'll see what I'm talking about when it starts getting confusing, and then you should say, whoa, I should use a tree diagram. Here we go. Leah is flying from Boston to Denver with a connection in Chicago. The probability that her first flight leaves on time is 15%. If the flight's on time, the probability her luggage will make it to Chicago is 95%. But if the first flight is delayed, the probability that the luggage will make it on time is 65%. Suppose you pick her up at the airport and her luggage is not there. What's the probability her first flight was delayed? So I see if the flight is on time, then it's going to have 1%. But if the first flight is delayed, it's going to have another percent. I see two conditional statements here. So what I want you to think in your brain then is, let me organize this in a tree diagram. Okay? So let me walk you through it. Here we go. We're going to start with Leah. And she's in Denver. And we know that the first thing that's going to happen is that her flight is either going to leave on time or her flight will be delayed. And that's 15% chance it will leave on time. And so what's the likelihood of it being delayed? All right, 85%. Okay, now let's see what starts happening. The first conditional statement is this. If the flight leaves on time, the probability that her luggage will make the connecting flight is 95%. Okay? So what part of the tree is it talking off? What branch? The top one, because it's about being on time. And so I've got either the luggage makes it, so I'm going to put luggage check, or the luggage does not make it. So I'm going to put a luggage X. And those percentages are 0.95. And what one's down here? 0.05. Good, because those two are the things, the 100% of what's going to happen if she's on time. All right, now let's read the next conditional statement. The next conditional statement says, if the first flight is delayed. So where on my tree diagram am I? The bottom branch. So now I'm talking about stuff happening here. And my luggage, the probability that my luggage will arrive on time is 65%. And the probability my luggage will not arrive is what? 35%. Okay. Now, here comes the question. Suppose you pick Leah up at the Denver airport and her luggage is not there. What's the probability that Leah's first flight was delayed? So the question is, what's the probability that her first flight is delayed? However, I was given some information. What information was I first given? Yeah, so given that her luggage was not there when you picked her up, what's the probability that her first flight was delayed? Okay, so that's the question we're trying to answer. Okay, so think back to how we did our last 2 days, yesterday and then the Friday before Thanksgiving. How did we handle these given that type statements? What did we first do? The bottom, the denominator was our first focus. Remember we said, oh, this is the entire bottom of the denominator. So I need to put all of the ways that her luggage does not arrive as the denominator of my problem. Okay, well, let's do that. Let's see here. Where in my picture does the luggage not happen? Good. On time and does not arrive, or delayed and does not arrive. Those are the two ways that my luggage does not get there. So how would that look in my denominator? Okay, on time, not there. So this is on time and not there. See multiplication? Or is my adding? What's the other way? 0.85 times 0.35. So this is the delayed and not getting there. So those are that's the denominator. No, that's the denominator. That's the whole ways, both ways that it might not get there. One of these pieces goes on top. So the parts on top and the holes on the bottom, what parts on top? The delayed is the question. Given that the luggage wasn't on time, what's the probability it was delayed? So the delayed one goes on top, and it is not just 0.85, people. It is the delayed and, remember, it's the delayed and the luggage doesn't get there. It's not just all the delayed. Okay, so if you go through this multiplication, you end up with this answer. 97.5% of the time that her luggage wasn't there, then she had had a delayed initial flight. Her first flight had been delayed. Okay, I want you to see if you can sort through this second one, okay? So try that one. I'll give you a few minutes, see how you do. Okay, so let's see if you got your chart correct. I did do happy face. I was like, did you see what I was doing? Because I did happy and sad, yeah. Okay, so this is what the story was telling us. Okay, so you can see if you got your conditionals organized correctly. And then the question was asking, what's the probability that he picked a first bottle given that his pain was not relieved? Well, if you got 81.81%, you got it right, and you can go ahead and go on to the assignment, which is the next page. But also, by the way, let me go ahead and tell you this, and then I'll go on, then I'll go back. Because I'm bumping up the quiz from Thursday to Wednesday, then I'm going to make it such that you're going to do page 20 and 21. But also, I want you to do the warm-up, which is on 27 and 28. Okay? You can just completely, because I'm bumping up a day, you can completely omit page 26 altogether. We will not be doing that, but it's there if you would like extra practice. So therefore, the quiz has changed from Thursday to tomorrow. So you can go ahead and get started there. Let me finish this if you wanted help here. But go ahead and get started. I'm going to come and stamp you on your homework in a minute. Page 26 does not have to be done. Okay, so all the ways that the pain was not relieved. Okay, you guys listen up or be working on your stuff. Was first bottle and not relieved, or second bottle and not relieved. So that's the total ways that he's sad. And the question was the first bottle portion. So I have the first bottle portion as my numerator. Okay, and so that's how you got those answers there. All right, so again, you're going to do pages 20 and 21 for homework. Well, actually, I hope you finish it mostly in class. But 27 and 28 is the warm-up so that you're prepared for the quiz tomorrow. Okay? All right, so get working on that. I'll come around and stamp you and help you if you need help on this.